Hello all. This video will be looking at how to write any radical form in the simplest form, because it is one of the very important lessons when you're learning about geometry and about the Pythagorean theorem. So how do you write the simplest radical form? So how do you know is the question given in its simplest form or not? So when a problem involves square roots, you may be asked to give the answer in simplest radical form. Recall the radicand and the expression under the radical sign. So radical sign is nothing but the square root sign. The proper word for the square root sign is radical sign, right? So how do you know whether the question given is in the perfect simplest form or not? So if an expression containing square roots, is it in simplest form when the radicand has no perfect square factors other than 1? So if you cannot further solve for the square, that's like the square of 16, we can solve as 4. So if you cannot solve it further, then that is in its perfect square form, simplest form. Or the radicand has no fractions. So the radicand should also not have fractions, and there are no square roots in any denominator. So if there are no square roots, you cannot have a square root in the denominator, you cannot have any fractions in the radicand, and the radicand should not be having perfect square numbers. So let me teach you some rules which will be useful when we are learning how to simplify radicals. So the first rule which I would like to tell you is this one: the square root of AB. Now AB definitely represents two numbers which are greater than 0. So we can rewrite this radical question as square root of A multiplied by the square root of B, which basically we are doing is we are separating the two elements. That's what we are doing. So if two numbers are together, that means we could write this as a separate one. So if they both are separated, which means we can write them in a together. For example, say no examples I'll show you later. Now for now I'll just show you the roots. So the next rule we have is the square root of A over B. So this is in a fractional form. Now when you have this, now this should be a whole square root. We can again rewrite this as the square root of A over the square root of B. This can be written in this form again. Similarly, how we separated this, we can separate this and write this as well. And another important thing which I would like you to show is, if there are two square roots of the same number, that's a square root of 2 and a square root of 2, this will result in the same number. So you will see how it is useful later on when we solve the questions, but for now just remember, if there is the similar square roots of, say, instead of A, if it's 2, so if a square root of 2 and a square root of 2, if you have any question like this, the answer for this is going to be a 2. All right, so keeping these three rules in mind, let's see how do we solve radicals in its simplest form. So let me start with the easy example for you. So the square root of 36. Now the square root of 36, everyone knows it's 6. Why is that? Because 6 multiplied by 6 is 36, right? But what is the perfect theory behind this? We are going to find the prime factorization of 36. So break down it as the prime factors. So 6, 6, and then we have 2 and 3, and 2 and 3. Now write the factors down. So that would be 2 multiplied by 2 multiplied by 3 multiplied by 3. Now group these two. In each group put 2 factors, and then they come out as one factor. So that's a 2. So we could group this also as 1 and say it as 3. So this is going to be 2 multiplied by 3, 6, which we already knew the answer. The square root of 36 is 6, because 6 multiplied 6 is 36. This is how you find the square roots. Now because this is a perfect square number, the number is like this. So let's try one more. How about the square root of 81? By mental math, we know the square root of 81 is going to be 9, right? But what's the theory behind it? You will do the prime factorization for 81, which is going to be 9 multiplied by 9. Then further, you will break down it into prime factors as 3 and 3. So for this question, we have 3 multiplied by 3 multiplied by 3 multiplied by 3. So group them in 2 each. So in one group there should be 2 factors. So that means this is going to be 3 multiplied by another 3, which is going to give you a 9. So the 81 is a perfect square number. So the square root of 81 is going to be 9. Now what if some of the numbers are not perfect squares? What are you going to do? Let me show you what you need to do when you do not have perfect square numbers. Let's take the square root of 216. Okay, so do the prime factorization for 216. That would mean this is 3 multiplied by 72, because 3 sevens are 200. 3 multiplied 72 or 216. You could use any other factors if it works. So 3 is a prime number, we leave it like that, but this we will further break down to 9 eights, and then we have 3 threes, and again we have 2 fours, and then 2 twos. So let's arrange the factors now. We have how many twos? 1, 2, 3. 3 twos. So that would mean, let me write it down here. 2 multiplied by 2 multiplied by 2, and then we have 3 threes. So 3, 1, 2, and 3. So what you're going to do next is you're going to group them. In one group there should be uh, 2 numbers, 2 factors. So this is one group. Now this cannot be grouped because it's alone. It's only one factor, so we don't group it. So we write this as a 2. And again, I can group a 3 here because there are 3 threes, and so we can put them in one group. So 2 multiplied by 3. Now what are you going to do with this left out numbers? You are going to write them inside the square root. So that would mean multiply them. 2 threes are going to be 6, right? So 2 threes will give you a 6. And then the square root, 2 multiplied 3 is 6. So the simplest form of 200, the square root of 216 is 6, the root of 6. So this is how you write the answers in simplest Radicand form. So let's try one more. If you could, do pause the video for this question, solve it by yourself, and then you can check out the answer. So you can pause the video here, do the question, and then check the answer. So the prime factorization for 720 is going to be 9 multiplied by 80, and then 9 will be further broken down into 3 and 3. 80 will be broken down into, say, 8 and 10. It's totally up to you. You can take 2 and 40 also. So 8 will be broken down further as 2, 4, and 10 will be broken down as 2, 5. 4 will be broken down as 2 and 2, right? So let's write the prime factors first. So how many 2's do we have? 1, 2, 3, 4. So we have 2 4's, 1, 2, 3, and 4. And then we have 2 3's, so 3 and 3, and then we have a 5. So let's group them now. So to group them, we need 2 in each group. So that's a 2. Again, another pair of 2 and a pair of 3. So this can be written as 2 multiplied by 2 multiplied by 3. And then this is alone, so we put that inside the square root. So your answer for this question is going to be 2 2's are 4, 4 3's are 12 to the root of 5. So this is the simplest radical form. Definitely you could try with some more questions by yourself, right? It's better always you try out some more questions rather than only sticking to these questions, because practice is what will make you perfect. Right, now let me go a bit further and show you what kind of other forms would you get in radical so that we can simplify them. Let me start with this. The whole root of 3 over 6, 1 over 3. Okay, let me take the easy one. Okay, so this is one of the radicals which you need to write in simplest form. Now, before I started, I did give you a rule where you could say this whole root of a over b, we could separate it like that. So the same thing we are going to do here. We are going to separate 1 over the square root of 3. Right? Now, what are you going to do next? Now, remember the rule for when writing simple is that there are no square roots in the denominator. So you cannot have a square root in the denominator. Now, to remove this denominator, we need to rationalize, right? Rationalize the denominator. We multiply the numerator and denominator of a fraction by the radical. So we need to multiply both the numerator and the denominator with this. Okay, so we are going to multiply. Let's extend this. Okay, let me write it again. So root of 1, we are going to multiply with the root of 3 over the root of 3 and root of 3. Because to remove this, to rationalize means to simplify this. We cannot have a denominator with a radical sign. So to remove this, we need to multiply the numerator and the denominator with the same number which is in the denominator. Now again, going back to the rules, can you see that I told you when there are two numbers here, if it is a and a, that would result in a simple number. So similarly here, we have the same. So that would mean the square root of 3 would give you a 3. Right? And then what are you going to do with this 2? This 2 could be written as 1 multiplied by 3, which is going to give you the square root of 3 over 3. Let's try one more. So this is the question for you. Try to do it by yourself and then check your answer. So I could give you 3 over 16. So try to do this question by yourself. Pause the video here, do it by yourself and then check your answer. So definitely you need to write it separately as the square root of 3 and the square root of 16. Separate them. Then to remove this radical sign, we are going to multiply the numerator and the denominator with the same radical. So 3 we write this as 3 and then multiplied by 16, right? Divided by the square root of 16, the square root of 16. Now this always you will do if you have a radical sign in the denominator. So square root of 16, square root of 16, that will result in a 16. And this could be written as 3 multiplied by 16 because you can combine them together. So 3 multiplied by 16 is going to give you 48, right? So this could be written as the square root of 48 divided by 16. Now we are going to find the square root of 48. So to find the square root of 48, we need to do the prime factorization for 48. So if you do the prime factorization for 48, you would end up in 412 and then 2, 2, 3, 4 and then 2, 2. So that would mean we will have 2 multiplied 2 multiplied 2 multiplied 2 multiplied by 3. So group them as 2's. So we have 1, 2, another 2, and this goes inside the square root. So that would mean this is 4, the root of 3. So we will write this as 4, the root of 3 over 16. Now again, you have a 4 and a 16, which means we could simplify this. So 4 ones are 4 and 4 fours are 16. So the final answer, 1 is not going to do anything. So the root of 3 over 4. Right? This is how you simplify radicand. Or there is another way. From here you could follow this, from this part. You know that the root of 16 is, from here you could follow. You know the root of 16 is 4, right? So let me draw an arrow here. Now this is the perfect way of doing it with all the steps. Or you could say the root of 16 is 4. You already know that. So you could write this simply as the root of 3 over 4, which means both the answers are same. Now, like me, if you were not vigilant enough to find the root of 16 here, you would end up doing all this. But then either ways, this is the correct way of doing it. This is the shortest way of doing it, because if there is any square number inside the square root, that means we could solve it in this way. Square root of 16 is 4, and then the numerator remains the same. But according to the rule, this is the perfect way of doing it, because to remove the square root, we need to multiply the numerator and denominator with the same denominator number. So that's what we have done. However you do, that will end up in the same answer, right? So again, I'm telling you, do some more questions for your practice, because this is one of the very important lessons in algebra, as well as especially for geometry, you will need this, right? Now, another kind of question you would end up is where you have something like this. So the radicand will be in the denominator. Now, well, you know, you cannot have a radicand in the denominator, right? So what are you going to do? You have to multiply the numerator and the denominator with the same number, the same radical, which is in the denominator. So this would give you 2, because that's the rule. And then this would give you 6 root of 2. Now simplify this. 6 divided by 2 would give you a 3, the root of 2. This is how you simplify these kinds of radicals, right? Now, definitely students, you do need practice. Practice is the only way you could get these answers, right? So you could try this question by yourself. Pause the video here. You can try the question by yourself. Now, if you have done that, so the answer for this is going to be 12, the root of 3, because we need to multiply the numerator and the denominator with the same denominator radicand, right? So that would result in a 3, because that's giving you a 3, and 12, the root of 3. So 12 divided by 3 would give you a 4, and root of 3. Isn't that surprising how the question is different and the answer is totally different? So this is the simplest form of radicands you will find. Okay, now another kind of question which you might come across when you're simplifying is when the radicand is in the numerator. So you would find something like this. Now what do? When you have something like this, when the radicand is in the numerator, you have to find the square root of 20. So the square root of 20, how do you find the square root of 20? Definitely by prime factorization. So we have 2 10s and 2 5s. So that would mean 2, 2, and 5. So we could group the 2 as 1, and then this goes inside, right? So the simplified form of square root of 20 is 2 over 5. This remains the same. Now again simplify that. 2 divided by 2 is going to give you a 1, but that won't. 1 multiplied by the root of 5 is going to be 5. So these are the different kinds of questions which you might come across when you're doing the Pythagorean theorem questions, or when we are doing about the special right triangles, which we will be learning in the later lessons. So do take some more questions. Definitely there are so many questions available. Do practice, because when you practice, you might come across different kinds of questions, and your mind will get trained to do such questions. So hope you understood this, and again what I would say is practice, keep practicing, it will become easy. It's easy, it's not anything difficult. So till we meet again, keep practicing.